All right, now I wanted to do number 23. That's the difference quotient problem. And so that's the one that's going to use that formula, f of x plus h, take away the original function f of x, divide everything by h. And we looked at it by figuring out f of x plus h. We already have f of x, plugging in for those two areas, and then once we simplify, dividing by h. So to get f of x plus h, we kind of worked on that. So we took the f, and in place of the x, we put an x plus h. And when we did that, it meant that everywhere you had an x, you were going to put an x plus h. So that means you would do 2 times the x plus h squared plus, and now right here we got to put the x plus h, and then add the 2. So in wherever there was an x over here, we replaced it with an x plus h. So let me finish working that out. This was hard for you initially to remember to write it twice. So that means you have x squared plus xh plus another xh plus h squared. So you have like terms there in the middle. So there's a 2 out in front. Then you have x squared plus 2xh plus h squared, and then plus x plus h plus 2. All right, so we're going to distribute the 2. That becomes a 4xh, and then 2h squared, and then bring the x plus h plus 2. All right, so this needs to go where f of x plus h is because it's equal to f of x plus h. So right where the f of x plus h is, that's where I'm going to replace and put 2x squared plus 4xh plus 2h squared plus x plus h plus 2. So that's in the circle, the oval, okay? Then I'm going to be subtracting, and in place of f of x, I'm going to put what it was defined to be, which is just 2x squared plus x plus 2. And then all of that will be divided by h when I'm finished. All right, so we have some simplifying to do. So it's like this is in parentheses and this is in parentheses. But there's an understood 1 in front of that, understood negative 1 in front of that one. Okay, so we're going to come in and subtract 1, or not subtract 1, distribute a negative 1, to everything, which changes the signs there. Okay, so what happens is 2x squared goes, the x goes, the 2 goes, and what I have left is a 4xh plus 2h squared. Don't leave off that plus h divided by h. Okay, so that h is really underneath each of these. It's distributed into each. Okay, so we wind up with 4x. We wind up with one of those h's canceling. So that's a 2h. And then don't completely get rid of the h over h. There's an understood 1 left on that. Okay, and so this would be the final simplified answer, okay, for your difference quotient. Turns out to be that right there. As good as it gets. Okay, now besides difference quotients, we got into combinations and composition of functions. So let's look at a couple of those. We'll do some of this tomorrow also. Let me look at 24. So this one had 2 functions, 2x squared minus 9x plus 7 was f. The g function was x minus 1. And on this particular one, they asked me to do f minus g of x. So that's the one where I'm just going to figure out what f of x is and then figure out what g of x is and replace f of x with what it's equal to, replace g of x with what it's equal to, and then this was a minus sign right here. Okay, that I'm warning you, that's where the mistakes are. So this is a negative 2x squared minus a 9x plus 7 minus x plus 1, minus a negative, plus 1. And then you simplify as much as you can. So we get minus 10x plus 8, negative 2x squared. That wasn't a negative. Darn it. Okay, I don't want to have to redo my whole video. This was not supposed to be negative right here, so let me just knock that little negative out. That was an equal sign. See how bad my writing is? You'll get into trouble like that too if you're not careful. So this was supposed to be just a positive 2x squared, so let me just change that. And so here at the end, we'll have 2x squared minus 10x plus 8, okay? All right, so that's, difference. And then I asked you to do another one that's a difference, a combination, but I get into domain. So let's look at that as well. So this is number 25. But this time I give you two functions. One of them's square root of x. The other one is x minus 11. And I ask you to think about f divided by g. Okay. So that's really just f of x on top, g of x on the bottom. Right? That's not the fun part. The fun part is the domain. Okay, when you're looking for the domain of f divided by g, you have to think about this. Remember how these two functions are next to each other? Okay. And so you got your f and your g. The input has to be able to make it through both of these. So x goes in, what comes out is f of x on the end. What comes out over there is g of x, and then we're going to do whatever the operation was. In this case, it was dividing. After they come out, but they have to make it through. So what you do is you look at the domain of each one. So the domain of f is just going to be from 0 on up, isn't it? The domain of g, well, that's not very interesting. That's just going to be from negative to positive infinity. Okay, but now you got to think about how when you do division, you introduced a trouble spot. So you have to watch out about that. Okay, so you need your inputs to be bigger than or equal to 0 and not equal to 11. Otherwise, you'd get division by 0. So if you think about that, bigger than or equal to 0, but not 11. So include the 0, go to 1, don't include it, and keep going. Go to 11, don't include it, and then keep going. So it's 0 to 11, bracket, parenthesis, and then 11 to infinity. Okay. All right, so that's that. In this video, we looked at difference quotients and we looked at combinations, arithmetic combinations, where you're adding, subtracting, multiplying, or dividing. All right, so that's a good stopping point. I'm going to do composition on the next video.